Hello and welcome to a new video. In this video I want to show you how you can get started with GitLab Webhooks. If you'd like to see how, stay tuned. For this demo I'll be using a free GitLab.com account. I'll be using Linode and run a Ubuntu instance on which I will be running a Python Flask application. Here I am in my GitLab instance in my repository or project Webhook demo. And let's take a look at the setup here first. So in my repository here, I have two branches, my main branch, which is my default branch, and I have a dev branch. And if we take a look at the contents of these branches, in my main branch, I have nothing other than my README file, and on my dev branch, I do have a GitLab CI/YAML file and a README file. So let's take a look at webhooks. Now, what is it actually that you can do with a webhook? A webhook is something that you can set up, in this case here, in this demo in GitLab, that will automatically send data over to another system when a certain event has happened. In the free version of GitLab, you can set up webhooks on a repository level. And the way that you would do that is if you're in your repository and you go under settings, and then under settings, you will find here webhooks. And if you click on webhooks, you can provide the URL. And then you can also go ahead and provide the trigger. The trigger is then defined as, for example, push events. So if I select the trigger push events here, and you can then decide what branch, while pattern, regular expression, or all branches. What you can do then is you can provide a URL, and data for this push event will then be automatically sent in a JSON format to that URL. And when you browse a little bit through it here, you can see it's for push events, tag push events, comments. You can read through it. In this demonstration, I will show for merge request events and for job events. For this demo, I have set up a hook already. So we can go in here and I can click on edit and we can take a look. This is my URL. So this is actually my Linode instance that is running. And then this is the webhook endpoint that I've created. I will go through the Flask code that I've set up on this instance in a little bit. And then you see here, I have set it up for push events. I have set it up for merge request events and for job events. So in this case, if either of these events happen, information will be sent to this endpoint. And then you can save it. I disabled SSL. If you set this up in a production environment, I strongly encourage you to set up SSL for brevity and ease of use. And for this demonstration, I did not set up SSL. So in the end, the demonstration will look as follows. Seeing that we have it set up for job events, merge requests, and for push events. And if I'm going back into my repository here under my dev branch, the expectation is now that when I make a change or push something to any branch, that information should be sent to my webhook. That if I'm running my pipeline, in this case, we can take a look at this. I've set up two stages here, job execution, job 1, job execution, job 2. And then I have two jobs here. The first one is just echoing out that job 1 is being run. And the second one is just echoing out that the second one is being run. Job 2 is dependent on job 1. So the expectation here would be with each job that's being run, that data is being sent over to my webhook. And lastly, seeing that these changes are in my dev branch, when I create a merge request from dev to my main branch, we would expect also data to be sent over to our webhook. Next, let's take a look at the Flask code and pick that apart a little bit. Here I am in Visual Studio Code, and this is my Flask application that I'm running on my Linode server. Here I have my init.py and I have a routes.py. So first let's take a look at init.py. I'm importing Flask, and then I'm creating my Flask application, and then I'm importing my routes from Flask app. Let's take a look at routes, and here's my routes.py. I'm importing requests from Flask, I'm importing app from Flask app, and then I have defined 2 routes here. So the first route is just on the root, and I've just created that so I have an easy way of testing that I can make a connection to my Linode server and that my web page really is being served there, or my application is being served there and the endpoint can be reached. That's the only reason for this. And then I have a webhook route. My webhook route here only accepts post methods, and I have defined my function here. If the method is a post, then run the function process data and send the JSON that's being sent from my webhook into my webhook receiver here, send that to process data. And if we take a look at the function here, it doesn't do anything other than just printing out some information. It extracts some data from the JSON data. After that, I have an if clause here. I left it as an if and elif in case I wanted to add some more. For this demo, I just left these 2. Didn't feel like changing it. So not the best way to do it, but that's how I did it. So what I'm saying here, if my object kind that's being sent in my JSON is a build, then go to job execution. And if it is a merge request, then go to merge requests. I did this to demonstrate on a very high level and very simplistic how you can then take data that's been sent through the webhook and how you can then further process it. So you can go ahead and take the data that was sent over or received here. You can go through it and execute other functions and process this data, maybe writing it to a database or making a decision or something along these lines. And then all I'm doing here is at the very end, I'm just printing out the entire JSON that was sent over to demonstrate what kind of data is being sent over. And in the end, we just return data received. And that's all there is to it, to my Flask application. Again, it's running on the Linode instance on Ubuntu, and it's running behind Nginx. And that's pretty much the setup there. So let's go ahead and switch over to the terminal and fire the application up. And let's demonstrate how these webhooks actually will work and what data is being transferred. Here I am now in my terminal. I have SSH'd into my Linode instance. I've prepared the code there. It's outside of this tutorial to show you exactly how to set up a Linode server or a Linode instance, run a Python application. If you do want me to demonstrate that, please feel free and leave some notes in a comment, and I'll be happy to make a video about that. What I did miss to mention is that I'm running it on Unicorn. And so we are having a setup here, Ubuntu instance, Python Flask, and then we're using Nginx and Unicorn. So let me go ahead and fire up my server. So now I have started my application and it is ready to receive information and data. And to demonstrate that the application is really running, we can go ahead and use that initial start route at the root that I've set up to test and see that my application really is running. So let's switch over to my web browser and take a quick look. So here I'm in my web browser. Let's go ahead and browse to our application, HTTP, and then I'm just pasting the IP address in here, HTTP only because I did not send up SSL. For this demo, I did not do that. And let's hit enter, and you see here, hello there, which indicates to me that my application is being served on my Linode server. Let's return back to GitLab. Here I went ahead and I've split my screen. You see on the right hand side my terminal where I've SSH'd into my instance, my Linode instance. And on the left hand side you see our webhook, or my webhook that I've set up on GitLab. So first things first, once you set up a webhook, you may want to test it. And the way that you can do this on your webhook or webhooks that you've set up, you have a little selection here on the bottom where you can test. And what you can do here now is you can just open this drop down, and let's say we want to test job events. So what this will do, it will just send some test data over to through the webhook, in my case, then to my webhook receiver to test my connection and to test if the data is being processed the way that it should be. So let me click on here. And as you see here, my data came over. So let's take a look at this, what has actually been sent over. I also want to note here, I did make a quick change to my Flask application so that the data has actually been pre-printed, which for those of you who are familiar with Flask may have noticed, if I would have left the code as I showed it previously, it would have been just the JSON data, the JSON document that would have been, or object that would have been printed. It would have been very messy. So this way, at least it's nice and pretty printed. With that being said, though, once I test here my event, you see it came through. The data being received is regarding a build. So this was a job event that we did test, that I did test here, do something with the job data. And then this data that's being sent over, as you see here, object kind, when the build finished. You see further information in regards to the runner that's being sent over. So what runner this job runs on, your project ID, the project name, the user who executed the job or who's currently logged in, the commit that has been included here has been run, and then the repository. So let's take a look at how this actually looks in action outside of testing. To demonstrate that, in my GitLab repository, I did not clone this, so I'm just going into the GitLab Web IDE or do an in-place edit in this case. So I will just make a change to my README file here. Let's go on the dev branch into my README file. I'll just simply go into edit, and let's just add a line in here, and let's just say test entry. And what I want to do now is I just want to commit this and push, and that then should trigger that I will have data sent over to my webhook receiver. Now that I've triggered my commit and my push to my dev branch, there's a lot more information coming through than just my single push event. And the reason for that is when we push to a branch in GitLab, the pipeline is being triggered. And in this case here, the webhook is also set up to send information to my webhook receiver when a job is being triggered or a job event happens. So this is the beginning of when data was sent over to my webhook receiver once I made the push and the commit. And you'll see here it starts out with the build event, which is a job event. And I can now exactly see here that this job, so the object kind here is build, was triggered on the dev branch. And I can see the job name here, and I can see the status. So I can see job 1 has been created on the dev branch in a dev branch pipeline. You get the date and the timestamp. And then if I scroll down a little bit, so there's information in here too, the user, the commit, the repository, if there's an environment set up. And then my next one is another build. And this is another job event. And I see that job 2 has been created. And I can exactly trace down what's going on. Now, this may not be in the order that the events happen. This is just the order in which the webhook receiver has received this information and it was displayed. But you have the timestamps, so you can go ahead and order that out accordingly. Here now is my push event. So this is when I made the commit and the push, and the object kind here is push. And you see exactly the detailed information for this push, what project, the commits, how many commits were in that push, any other push options, and the repository information. And then we have another job event. And in this case, again, it is job 1 has now changed to pending. And if I scroll further down, another job event, job 1 is now running. And if I go further down, another build event, job 2 is now pending. So I would expect job 1 to be either successful or failed. And here, job 1 now shows as successful. So I can see when it was created, when it started, and when it finished upon my success event. So if you really wanted to, you could go ahead and receive all this webhook information, look for the object kind build for jobs. If you know the job name, filter by the job name, look for success or failure, and then you can extract the dates here and the timestamps, and you know exactly when what job ran on what branch, and possibly even the environment if one is set up. So this is pretty much what's been sent over. This is now repetitive in the sense of that for job 2, we got the same thing. It's in running. If I go further down, job 2 here is successful. And that is it. So my pipeline only has 2 jobs. And both jobs ran successfully. My push happened. And now I can, on a separate system, monitor and track it if I wanted to. So let's take a look how it looks like on a merge request, if my webhook is triggered there too. So in order to do that, I will go ahead and create a merge request. So we'll go into merge requests here. I will create a new merge request. And my source branch is dev. And I want to have my target branch as main. Compare and continue. I just leave the title as dev. I'm not doing anything fantastic here. I don't want any approval. I'm not changing anything there. I do, however, not want to delete my source branch. Let's put a message in here. Why not? This is a webhook demo. Let's see if that pops up in my data here somewhere. So once I have everything set up in my merge request as I want to, I will go ahead and create my merge request. And as you can see here, my data came over. So let's take a look. What do we have in our merge request data? And there's obviously quite a bit. So data received is regarding my merge request. Do something with the merge request data. Object kind is clearly merge request. My event type, the user, the project, some project information, object attributes. Oh, and here's my description. This is a webhook demo. So this is very interesting because now you can theoretically enforce certain merge request information to be added to a merge request. You can extract that and then further process that. Maybe trigger other processes or something to that extent. Depends on your needs, what you need to do. But you have all the other information in here that you need, and it's all coming nice and clean in a JSON format, and you can use that. One more thing in regards to merge requests is too that not only when a merge request is being created or the merge request is being approved or merged, another thing too is that you can track, for example, when a merge request is being closed. So the merge request that I've just created, let me go ahead and close that. And let's take a look at our terminal and see what information is coming through. So if I click on close merge request, you see here the merge request event was triggered and information was sent over to my webhook receiver. And you see here merge request data. And then if we're scrolling down a little bit, we should eventually find that this merge request was closed. And then you see here, my state is closed. And this indicates then that this merge request has been closed. So what happens if I open this merge request again? Let me go in here. Let me reopen the merge request. And you see there was information sent over. And you see here, action, reopen. And what happens now if I merge my merge request? Let's go ahead and merge it, and you see all this information coming through because now again a pipeline has been triggered and I get all my pipeline information. I will not scroll through everything here, but it should suffice to know that now because I have now merged. So the merge event has been triggered again, and now also my pipeline is running, so my job events have been triggered, and that's been sent over as well. So that's just to demonstrate how far these webhooks go and what you can do with them. This concludes this short demo of GitLab Webhooks. I hope you found this helpful. The Flask application code, I will put the link in the description. And please feel free to leave comments if you liked my little demonstration. Thank you very much for watching, and see you the next time.